In this video, we're going to talk about how to calculate the internal resistance of a battery, as well as the battery's terminal voltage. So let's draw a circuit. This is the circuit diagram for a battery, and here it is for a resistor. And now we're going to attach it to another resistor. This portion of the circuit is the battery itself. The battery has its own internal resistance, which we'll represent with the symbol lowercase r. And it produces a voltage, or EMF, also known as electromotive force. That's the actual internal voltage of the battery. But when you connect the battery to a device, the voltage that you read is not always the same as the EMF of the battery. The voltage that you read, we're going to call it VR, which really is the terminal voltage. And typically, when you connect a battery to a device, that device will have its own resistance, which is represented by capital R. And the voltage across that device is the terminal voltage. Now, whenever you connect a battery to a device, the device will draw current from the battery. And as the battery delivers energy, it turns out that the terminal voltage will decrease. As the current increases, the terminal voltage will decrease. It kind of seems counterintuitive because V equals IR, you would think that if the current increases, the voltage will increase. But it turns out that the more current that you draw away from the battery, the greater the voltage drop. The terminal voltage will be less. And we'll do some calculations to show that. So let's calculate the terminal voltage of a battery when the resistance, or sometimes called the load resistor, let's say when it's 1 ohm and when it's 100 ohms. And let's say the voltage of the battery is 12 volts. So let's say that's the EMF of the battery. And let's say that this particular battery has an internal resistance of 0.1 ohms. So with this information, go ahead and calculate the terminal voltage when the load resistance is 1 and when it's 100. The first thing we need to do is find the equivalent resistance of the circuit. Now, these two resistors are in series. There's one path that connects them. So it's just R plus capital R. So that's using a value of 100. Let's start with this one. It's going to be 100 plus 0.1. So that's 100.1. Next, find the current that flows through the circuit. The current is going to be equal to the EMF divided by the total resistance. So that's a voltage of 12 divided by 100.1. So the amount of current that flows in the circuit is 0.11988. So now that we have this current, we can calculate the terminal voltage. So we could just use the current multiplied by R. So 0.11988 multiplied by the resistance of 100 ohms will give us a terminal voltage of 11.988 volts. So as you can see, if the device has a significantly high resistance, it's going to draw a small amount of current. And this is going to lead to a small voltage drop. The EMF of the battery is 12 volts, but notice that the voltage across the resistor, the terminal voltage, is just under 12. 11.988 is very close to 12. So when you draw a small amount of current from the battery, the voltage drop will not be significant. It will exist, but it's very, very small. Now, let's see what happens if we decrease the resistance. If we connect a battery to a device that has a very low resistance. If you decrease the resistance, there's going to be more current. And if we draw more current away from the battery, the terminal voltage of the battery will be less. So let's go ahead and show that. So let's follow the same steps. Let's calculate the equivalent resistance. So we're going to add 0.1 and 1. So the equivalent resistance is now 1.1 ohms. Next, let's calculate the current. The current that flows in this circuit is going to be the EMF divided by the equivalent resistance. So that's 12 volts divided by 1.1 ohms. So 12 divided by 1.1, that's about 10.91 amps. So as you can see, the current is much greater than what it was in the last example. Next, let's calculate the terminal voltage. Let's use this equation, E minus IR. So the EMF is 12, the current is 10.91, and the internal resistance is 0.1. So this will give us a voltage of 10.91 volts. Now keep in mind, you can also use this equation. It's just I times R, or 10.91 times the resistance of 1, which will give you the same answer. So notice the voltage drop is much greater. The EMF is 12, but the terminal voltage is 10.91. It's no longer 12. And the reason why the voltage dropped a lot is because a lot of current is being drawn away from the battery. And so it experiences a greater voltage drop. Now let's try another problem, but with the same circuit diagram. This time, we're going to focus on calculating the internal resistance. So let's say the voltage of the battery is still 12 volts. That's the EMF, the electromotive force. And let's say that the load resistor, or the resistors that is attached to the battery, let's say it's 50 ohms. Our goal is to determine the internal resistance. So once you connect the battery to a resistor, there's two things you need to find. Well, actually, there's one thing you need to measure, but there's something else you have to find first before you could find the internal resistance. In order to solve this problem, you need to measure the voltage across the resistor. And you could use a voltmeter to do that. So once you connect the voltmeter across the resistor, it's going to read a voltage. And that's the terminal voltage. So let's say in this problem, the terminal voltage is 11.9 volts. With this information, calculate the internal resistance of the battery. So what's the first thing we need to do in order to calculate the internal resistance? So after we measure the terminal voltage with a digital meter, what should we do? The next thing we need to do is find the current that flows through the circuit. We have the voltage across the resistor, and we have the resistance of the resistor. So we can use the equation V is equal to IR. Solving for R, it's going to be the terminal voltage divided by the load resistor. So it's 11.9 volts divided by 50. And so that's going to be 0.238 amps, or 238 milliamps. Now, once we have the current that flows through the circuit, what should we do next to calculate the internal resistance? Once you have the current, use this equation. The terminal voltage is equal to the EMF of the battery minus the current that flows through the circuit times the internal resistance. We have the terminal voltage, it's 11.9. We know the EMF, it's 12. And the current is 0.238. So let's solve for R. So first, let's subtract both sides by 12. 11.9 minus 12 is negative 0.1. And that's equal to negative 0.238 R. Next, let's divide both sides by negative 0.238. So negative 0.1 divided by negative 0.238, that's 0.42. And so that's how you can calculate the internal resistance of a battery.